Homework 1, part 1, number 5. Ah, what was it? All right. 3, 4, 5. Ah, okay. Do you have a specific question about this problem?
I guess I'm just a little bit confused on the process. I'm not sure if I'm just like calculating it wrong because I've tried it a few times and I haven't been getting the right answer. So I'm not sure if it's just like a calculation error or something, but I guess just like the general process of how to solve something like this.
Okay, so let's see what's happening. Do you see the screen clearly?
Yeah.
All right. We know the masses. We know the length of the string. So what was your first step?
So I drew a right triangle of the forces.
Well, we call it free body diagram.
Yeah.
So we have a for which charge, on the left or on the right?
On the right.
So we have a string, the charge. How many forces do you have in your diagram?
2.
Well, that's already a problem.
I guess you have to draw the like X and Y components of the.
No, that's not this.
Oh, sorry. I have 3. The force.
Forces. How many should
3.
be? 3. What force is missing?
The FC.
The Coulomb's force, because they must repel each other, correct? So
Yes.
we should have 3 forces. And yes, you're right, they make a triangle. So the angle is given. And in our triangle, we've got, because it's in equilibrium, we've got this force plus this force plus this force should be 0. That should be triangle, that should be angle, that should be tension, that should be gravity, and that should be Coulomb's force. Okay. And you can calculate gravity because it is mg, which is the mass do you have?
I have 0.3 grams.
0.3 grams. How do you convert it into kilograms? Did you convert it?
Yeah, I did convert it.
So grams. And G is supposed to be 9.81 when you do the website. So this is your side number 1, and you know the angle. If you know gravity and angle, what can you calculate?
Either FC or T.
Both, of course.
Yeah.
You can calculate both. For example, mg over tension should be equal to cosine of this angle, and fc over mg should be equal to tangent of this angle. Technically, we don't need tension. We could have. It's just not now. But clearly, you need to calculate the Coulomb's force, right?
Mm-hmm.
Mg tangent. And well, everybody has the same angle, so 0.3 -3rd 9.81, tangent of 10.
Yes.
So what is your answer for this value? Because you did it.
I got 5.18 times 10 to the negative fourth.
5.1 negative fourth newtons. Sounds reasonable range. 9.8, let me check. Sometimes it's just a matter of a simple calculation. So 3 times 9.81 times tangent, sometimes just wrong button. And your calculator is in degrees, right?
Yeah.
Well, technically, this is not 1/8. This is 8/9. So if you round up, you would have to keep. So you always should keep a little bit more digits. Sometimes it might be just a matter of accuracy.
Okay.
Now, what did you do next?
So I then set that value equal to k times the charge squared over the distance between the two squared.
Exactly. So everything looks correct, and you have to solve it for the charge. And what distance did you use? How did you find the distance?
So I did the sine of theta times the length of the string in meters, and then I multiplied that by 2.
You see, everything you're saying is correct. So this is exactly what should have been done. What is the length of your string?
10 centimeters.
So 0.1 in meters. The angle is the same for everybody. This is exactly a half of a distance you need to use. So R over 2 over 0.1 should be equal to sine of this angle, and the distance supposed to be equal to, well, basically 0.2 times sine of 10 degrees. 0.2 times sine of 10. So I got 0.03473.
Yeah, that's what I got too.
So the last calculation, your charge is supposed to be equal to square root of the force times distance squared over the constant. Well, actually, it could have been simplified, just R times force over constant. So 0.03473 times square root 5.1893 times 10^4, okay, divided by 9 times. Actually, this is what I want to check. WebAssign actually may be using 8.99. Electric charge shows no nodes. No nodes. So still, I want to just recheck in the future. K for the WebAssign. Is it 8.99? It should not make difference technically. But so what is your answer?
I'm just calculating it. I got 2.399 times 10 to the negative 7.
Did you have this answer before?
No.
So let's hope you didn't make mistake again, because clearly the strategy was correct. So you can try this number and see if it works.
Okay.
You know it's supposed to be a small number. Like in my example, it's about 3 times 10 to negative 8 coulombs.
It's still saying it's wrong, so I don't know what I'm doing.
Alright, what do I want? Oh, I just can move. I want to, what do I want? What do I want? Hey, Thompson. Maybe you could just give a key to me. As right now, I will give it back to you, but I just right now with the students.
And put it in here.
Thank you. What do I want? This is what I want. So 103473 times square root. I want to rewrite it 5.1893 -4, and this is what I want to write as okay, let's check it out. 9, but I want to make it differently. 90 times 10 to the 8th. 0.03473. This is 10 to the negative 2nd. This is 10 to the 4th, and I have left 5.1893 or 90. So this is actually 3.473. Second, something is off. Okay, times let's go to this. Square root 5.1893 over 19.2 times 3.49. Oh, that's not that. That's supposed to be Q. Yeah, that starts here from Q. 2 point. We had 2.9 again.
For the,
For the charger. But I don't have correct exponent. Something is a decimal point somewhere. Okay, so your string is 10 centimeters long, 10 centimeters, 0.1, and your mass is 0.3 grams. So this is supposed to be the coulomb's force. 0.3 grams times G times a tension of 10 degrees. How did you get this power? You should, let's calculate again the coulomb's force, this one. Point 3 times 9.81 times tangent of 10. No, this is correct. Yeah. So this is 0.51893 times 0. Okay, this is the force. So coulomb's force times distance squared divided by constant square root of r squared r, force r. Let's check your r again. R over 2 over the hypotenuse, which is 0.1, sine 0.2, so 0.2 times sine of 10 degrees. Was it degrees? Yes, degrees.
yeah,
0.03473 meters. And now this one. One more time. Distance, force, constant. Square root 10 is 8 gives 4. Square root -2. Oh, sorry. That's a silly mistake. This is wrong, of course. So that should be equal to 3.473 times 10 to the -2, -4, that's -6, and 2 more, -8. That's correct. So, and this is square root. So that's exactly what I had, 2.9. Well, let's check it again. So square root square root of 5.1893 divided by 19 times 3.473. Oh, I get a different number. 0.8339. One more time. Square root 5.1893 divided by 19 times 3.473 equals times 10 to the negative 8 coulombs. This is the answer, I believe now. After checking all steps of the calculation, this is supposed to be the answer.
Okay.
But you have to get your answer, and if it's the same, it means we both made correct calculation. Until you and I have the same answer, we cannot confirm.
Yeah. I got 8.339 times 10 to the negative 9, so.
Well, 8.339 times 10 to the negative 9 in coulombs, it's the same answer.
Uh-huh.
This is supposed to be correct answer. And
Does it matter in WebAssign how I answer it?
the answer is supposed to be written like this.
I can't really see the result word.
So this is 8.34 e negative 9.
Okay. Try that.
It actually has a 0 by some reason.
Okay, yeah, that
should not matter.
that works.
All right. So
Okay.
all your strategy was correct.
Okay. Thank you. I'm not sure why
But, your calculation and my calculation went sideways at some point. It could have been just pressing wrong button,
Yeah.
wrong digit, wrong symbol, something else. It's something with a calculator,
Okay.
nothing else.
Okay.
All right. Next
Thank
question.
you. My other question is kind of a simple question, but I'm just getting tripped up on it. And like, I'm just getting confused with like how to determine which way the like forces point when you have like 3 charges in a row.
You need to start from 2 charges. If you have 2 charges like this, what is the direction of a force acting on the charge number 1 from the charge number 2? Force on 1 from 2 points. Finish this sentence, please. Or you should ask a question. It's either or.
Well, like I know that they're like attracted to each other.
So first step, attraction or repulsion. How do you know they attract?
Because they're opposite charges.
Exactly. So attraction for the opposite, repulsion for like charges. Okay. So now we need to imagine what does it mean if the charge number 2 attracts the charge number 1. If a charge number 2 had a stick, would it be pushing on that stick or pulling?
Pulling
Pulling. The direction of that pulling is what?
to the right.
To the right.
Okay.
So what is the direction of a force acting on the charge number 1 from the charge number 2?
To the right.
To the right.
Okay.
All right. Now, what is the direction of a force acting on the charge number 2 from the charge number 1?
Left.
Left. Now let's take a look at two other situations. Let's say these two charges are positive. What is the direction of a force acting on charge number 2 from charge number 1?
Well, it's being repelled, so right.
Is the charge number 1 pushing or pulling the charge number 2?
It's pushing.
Pushing away, exactly. So the direction is to the
To the right.
on charge number 2 from charge number 1. So
Okay.
if you've got more charges, I don't know, in your mind, you need to break it down into pairs. How many pairs do you see here in my example? How many different pairs of charges?
3. Oh.
1 and 2, 1 and 3, 1 and 4, 2 and 3, and 3 and 4. All right, this is how many pairs you can make. For each charge, pick one, 1, 2, 3, or 4. Which do you want to talk about?
3 and 4.
Pick one charge.
Oh, sorry, 3.
3. For this charge, how many forces acting on it?
2. No, sorry, 3.
3. Every other charge exerts a force. So for this charge, you have 3 pairs to analyze. This and this, this and this, this and this. And for each pair, you can draw a force acting on the charge number 3, on the charge number 3, on the charge number 3, from another charge. So, what is the direction of a force acting on the charge number 3 from the charge number 4?
To the right.
Correct. What is the direction of a force acting on the charge number 3 from the charge number 2?
To the left.
Correct. And what is the direction of a force acting on the charge number 3 from the charge number 1?
To the left.
To the left.
Okay.
And how do you calculate the net force acting on the charge number 3? What do you do?
You add the vectors.
Exactly. That's why you need to know each individual force first, magnitude and direction, so you could add them. Okay, that's how it works.
Okay, thank you. That's really helpful.
All right,
Okay, I think those are all my questions for now.
thank you. Well,
Thank
my
you.
office hour is over anyway, so have a nice day. Bye.
Thank you.